Welcome to the University of Pittsburgh Health and Explainable AI podcast, a collaborative initiative between the Health and Explainable AI HexAI Research Laboratory and the Department of Health Information Management at the School of Health and Rehabilitation Sciences, and the Computational Pathology and AI Center of Excellence, CPACE, at the University of Pittsburgh School of Medicine. I'm your host, Jordan Goss-Poire, a health and science reporter. In this podcast series, we explore the transformative integration of responsible and explainable artificial intelligence into health informatics, clinical decision-making, and computational medicine. From reshaping diagnostic accuracy to enhancing patient care pathways, we'll highlight how AI is creating new bridges between researchers, clinicians, and healthcare innovators. Led by Ahmad P. Tafti, Houman Rashidi, and Liron Pantanowitz, the HexAI podcast is committed to democratizing knowledge around ethical, explainable, and clinically relevant AI. Through insightful conversations with domain experts, AI practitioners, and students, we'll spotlight the latest breakthroughs, discuss real-world applications, and unpack the challenges and opportunities that lie ahead in responsible AI in healthcare. So, whether you're a student, practitioner, researcher, or policymaker, this is your gateway to the future of AI-powered healthcare. Today, on this podcast episode, we're going to speak with Martin Raison, co-founder and CTO of Nabla. Nabla is a cutting-edge healthcare company and AI research lab that is playing a major central role in architecting the agentic AI era in healthcare. We're going to discuss this, and we're going to use this special opportunity to also talk about AI inference in computational health and inference optimization. So, welcome, Martin. Thank you so much for joining us. Would you like to introduce yourself and tell us a little bit about Nabla?
Yes, thank you. Pleasure to be here. So, quick word about myself. So, I've been in the AI space for almost 20 years now, when it went from being a very technical topic that not many people were interested in to something that is making headlines every day and is being deployed across all industries. For a long time, I've been focusing on the processing of natural language and building more and more powerful models that are able to understand the full complexity of human language. And now we're going also in a territory of processing other kinds of data, visual, sound, and or otherwise. And the mission of Nabla is really to use AI to restore the human connection at the heart of healthcare. So we think that AI is perfectly suited to do that. So unfortunately today, most clinicians spend an enormous amount of time dealing with administrative tasks to the point that, I'm sure you've had the experience as well. You go see your doctor and you see that they're actually spending more time looking at their computer and actually looking at you and trying to understand your problem, and that limits their ability to build empathy. And so that it has real consequences on the care outcomes. And so recently, AI models have become a lot more powerful at processing speech and human language, which enables Nabla to automate operations such as writing clinical documentation and also writing lots of various pieces of information in the right place in the medical software, and automate more and more clinical workflows that used to take a lot of time from clinicians.
For healthcare professionals, Nabla has invested a huge amount of work into streamlining its tools and making them intuitive and easy to use and easy to incorporate into existing digital systems. But obviously, on the back end, this takes a huge amount of technical work. Can you tell us about the challenges that your team has had to tackle?
Yeah, exactly. There are lots of challenges to solve. Also, of course, there's the AI problem itself. How do we build a model and an infrastructure that is able to process unstructured data in the medical space and to produce outputs with the very high level of accuracy that is required for the medical use case. And as you mentioned, there's also all the connections, the integrations that you have to build with the existing system. So in the case of a medical encounter, the data that matters is everything that is actually said during the medical encounter, but there's also what exists in the patient chart. You may also have some specific hospital guidelines, some preferences from the clinician. There's a whole lot of data that you want to include in your context and process in order to produce the best possible documentation. And so it's both an AI problem, but also an infrastructure and integration problem. And there's also the key question of adoption and how you actually roll this type of technology in hospitals, in small to medium-sized practices, and to individual clinicians. How do you build an experience that is easy to understand? A tool that is very intuitive. I think the goal is really to make the clinician's job easier. And so you can't, give them a tool that is too complex or that is changing all the time. So you have to make the experience as simple as it can be. In a sense, you want to present just the relevant information at the right time. And so I think that we really built Nabla with that in mind. And that has really helped a lot with adoption. Is one of the factors on top of course, the intrinsic utility of the product that has explained the very quick adoption that we've seen over the past 2 years.
Okay, this is a question that we normally save for the end of our interviews, but since our discussion has already become technical, what is your view on explainability and explainable AI?
Yeah, so explainability is something that is obviously very important, especially in the healthcare space, it's true in any high stakes environment. And so what's interesting is I don't think there's like a single definitive answer today to how do you make AI explainable, but there's lots of things you can do to make it a lot easier to understand the outputs of the model in the context of the use case that you're using it for. So first, we made the decision for the initial scribing use case to make sure there's always a human in the loop to actually review the outputs of the model. But still, the more clues you can give to the clinician as to why a specific piece of information was included in the generated documentation and where, the better. And I think the demand we see from customers is about both the explainability, but also the transparency. I can see that often they link the two concepts together. And I think what matters to clinicians using the product is, not only do I understand why some piece of information is there, but also how does the system actually work? It is good for them to understand both the powers and the limits of those kind of systems. It's also important when they have to explain what the system does to patients. In many settings, you actually need to obtain consent from the patient. So you want as much transparency as possible to understand, okay, are you using LLMs? If so, which kind of data were they trained on? How have you actually tested the performance on the specific use case that you're using it for, and so on. So there's a lot of effort that's being done on that front. And then I think on the core of explainability, there are lots of strategies today to have, sometimes multiple models collaborating and one model questioning the output of another one. And so you can get some kind of deeper explanations sometimes. But I think at the more fundamental level, there are some new model architectures that are being worked on, which make the overall reasoning process more explicit. And we're very, very interested in that space.
I wanted to ask you about your early research at Stanford to help us think about the data layer behind AI and the utility of graph databases. So, going back in time to Stanford, can you tell us about Project Ringo and why are graph knowledge bases so relevant to talk about today?
Yeah, so the Ringo project actually dates back to probably about 13 years ago or something now. And so really the challenge was that, most of the data that exists today in the world, like a lot of it presents itself naturally as a graph, whether it's graphs of, of people, of cities or websites or really anything. It's hard to come up with things that you can't, cast in the form of a graph. At the time, the reasoning was that like computers, machines were getting bigger and bigger, with more and more memory and processing power. And so for many use cases where we wanted to analyze graph data, what was previously done on large clusters of machines could actually be done in many cases on a single big computer, which unlocks, much faster processing. And so you can ask a lot more complex questions. So the typical questions you'd want to ask a graph would be things like, what's the maximum distance between 2 points in the graph? It's a very simple question. but then also maybe what are the clusters that exist in the graph? If there's like directions on the edges of the graph, is there like some parts of the graph that have like that influence another part and so on. So it's a very, very general concept, but there's lots of interesting questions you can answer this way. And I think another kind of a counterpoint to the utility of graph research is also that many times you have to simplify your problem so that it really boils down to a simple graph. A lot of data is raw text input, sound, video, and all that. And obviously, you also need to be able to process that. So I think the many years of work I did on natural language processing afterwards, I think part of it also arose from the kind of the frustrations that I had with dealing with graph-only types of data. But I think it's not an either or. It's really one of the tools that you want to have in your tool belt. And there's always been a constant stream of publications about doing machine learning on graph data, and it continues today. So it's one of the many ideas that are being explored.
Nabla is carrying out pioneering research and development work around agentic AI and agentic systems. What's challenging about agentic systems? Thinking about graphical networks and agent-to-agent communication?
Yeah, the agentic AI research we're still in the early stages, obviously, but already there are lots of ideas around, agent-to-agent communication and networks of agents that are being discussed. I think to be fair, there are lots of use cases that you can tackle already with, a small number of agents where you have, an environment that is easy to control because you know what the possible triggers and actions and inputs and outputs are. Well, you can have some agent-to-agent communication, but let's say the graph is very simple and very manageable. And we're tackling several of those use cases today. And where you're right that it gets more complicated is when you want to have discoverability of agents. And so typically, right now, we are building a platform where it's easy to create and compose agents and give them tools and manage what they are doing. But we certainly don't want to assume that this is going to be the only platform powering all the agents. And so we have to, on the contrary, we have to assume that whenever we deploy in a new environment, in a hospital, in a health system, there's going to be other systems, running agents connected to different types of data sources and different types of capabilities, and discoverability will become critical. You want to reinvent the wheel or have to manually integrate with all the systems that exist in the environment. You want to be able to discover what agent exists out there, who is powering them, what are they doing, what are the capabilities, and maybe the agents that are powered by Nabla will be able to make use of those other agents. And so then your agent effectively becomes a graph that you have to manage, you have to govern. There are like governance questions around, what agents are living in my system and what are they doing. And so there are many open questions associated to that.
Something that we plan to mention towards the end of our interview is that Pitt's HexAI lab has been following MIT's Project Nanda, headed by Ramesh Raskar, that's involved in architecting the foundation behind the agentic web. What's your take at Nabla on projects like Nanda and other agentic architectural initiatives?
So there are lots of great ideas out there. And so some of the most famous are protocols like MCP or A2A. And so, of course, we try to leverage those as much as possible. So things like MCP, for example, they are kind of firmly established now. And so there are good ways to frame, how you think about creating agents. Even if I don't think we're, very far yet in the actual networking of agents and discovery of capabilities, you definitely want to be prepared for it. And so if you're going to come up with a protocol, for example, that exposes a set of tools and capabilities, you might as well use MCP rather than roll out your own flavor of that is incompatible with everything else. So it's good to develop standards and refine them over time. I do think that the standards will continue to evolve quickly, especially as the capabilities of individual agents evolve. So I think the Nanda project in particular, I love the fact that it's really thinking about agents considering the complete stack, including addressing discoverability and all that, and not just the AI layer. I think there are still important aspects that are underdeveloped. There isn't yet a strong and final specification yet. So it's not just like authentication of agents and I'm proving that I'm the agent powered by this or that platform or person, but also being able to advertise, who am I acting on the behalf of, who is accountable for my actions, what's the level of criticity of the things I may do. If I'm getting, triggered by something, do I require human review and so on? So I think there's more context that can be standardized around agents, and that will be very important, especially for the healthcare sector. And so, yeah, that's a space that we're following very closely, and it's good to have at least attempts at having a common discussions and maximizing the chances of interoperability between agents.
All right, this makes me think of agent fax files, for example. Agent fax files are relatively simple documents, but it's a good time right now for the healthcare sector to come together to think about what information should be included in agent fax files and standardize some guidelines.
Yeah, exactly. And so there are things like the typical questions, who owns me? What can I do? How do you trust me? And I think all the other points around, specifically around accountability, which I think will be the key topic in healthcare, would also be very important to actually include in this type of fact file. It will make governance easier at an organization level to really understand and efficiently manage, many, hundreds or thousands of agents being deployed across the organization.
Do you have any thoughts on how companies like Nabla that started out in the scribing space have so quickly found themselves playing major roles in tackling underlying challenges, enabling the healthcare sector to experiment with agentic AI and agentic systems, for example?
So it's true that we started from very specific use case initially, which is the scribing use case, as you pointed out. And I think it's been a very long time since this type of technology was adopted so widely and so quickly within health systems. And the reason for that is really the immediate value and the pain point that it solved for many clinicians. I think there was tremendous amount of word of mouth across clinicians, across health systems that can explain that. And we found ourselves early on, partnering with the chief AI officers and scientists at those health institutions. They're not interested in point solutions, saying I want the specific solution that solves the scribing problem. What is important to have is an actual partner for automation of clinical workflows through AI. And because a lot of things start from the clinical documentation, it's very natural from the tool that handles the clinical documentation to expand towards other kinds of workflows. And so there are many examples. You have to think about the reason for writing clinical documentation in the first place, and there's like the being able to efficiently, pass context from one encounter to the next for, improving care outcomes. There's also all the billing implications for health systems, the reimbursements, where, if you don't code something in a very specific way, it's like it didn't happen. And that's actually a huge problem for hospitals today. And so typically you find yourself going from just clinical documentation to the coding and anything that's about the revenue cycle management space, and also things that happen before or after the encounter, things like the ordering, lab tests, referrals, prior authorization, pre-charting. There are lots of things that are connected to the documentation process that are very natural once you're there. So I think that's the main explanation.
Being a CTO of a company like Nabla that is tackling so many highly technical challenges behind the scenes, how do you cope with all the layers of challenges that you see every day that you didn't expect to have to contend with when Nabla got started?
Yeah, but I think the great thing is you can actually take it step by step, and every incremental step that you make is making clinicians' lives better and health systems happier. So, even if you don't tackle everything at the same time, you start from the most obvious use cases that will bring the most value. and that ensures you can actually properly address them with the same level of care that you had initially for the initial scribing use case. And all the use cases that we've had so far are things like we continue to invest deeply in, because you could consider that scribing is a solved problem, but actually if you zoom in, it's a bit more nuanced. There are many medical specialties that, like primary care, for example, that are very well covered. And then when you get to more and more particular specialties where the amounts of data that are available are maybe a little bit smaller, or there are like more and more specific requirements, but you also need to ensure that doctors operating in those specialties can get the same level of value that the first wave had when they adopted AI scribing. And also, I think as they get used to the tool, they want more and more from the tool. So initially, they are okay with having to make a couple of edits to the generated notes. But naturally, and it's great actually, they raised the bar over time. And so you want to make sure that you can adapt over time, that you can have a deep amount of personalization, both in terms of adopting specific health systems guidelines, but also specific clinicians' preferences. You want to act like actually a human assistant would. Like I can get some feedback when I write some clinical documentation, and then the next time, I can improve and do better and avoid the feedback that I received the previous time. And so that personalization, you want it to be very natural and not, you don't want to have an ever expanding set of settings and toggles and things that you have in a giant settings menu, because clinicians don't have time for that. Again, the goal is, saving them time. And so you want them to give their feedback and preferences, in English, or even you want Nabla to be able to infer them from the available context. And that requires actually a lot of investment and research. So it's really about expanding the set of use cases and also continuing to make the current use cases even better.
Talking about agentic AI in healthcare, how can universities play roles in helping teams like yours tackle frontier challenges? And where can we be most useful?
Yeah, I think there are many possible directions. I think it's when you enter the healthcare space, for good reason, you can't have like access to any kind of data that you want, and you don't necessarily need that. What's important though is trying to have as much visibility as possible on where the technology is having a great impact. Are there specific use cases where we aren't there yet? And the first thing we had to do initially was to deeply understand, in the everyday life of a clinician, what's the most pressing problem. And we built a good initial view of that, which allowed us to ship the initial version of Nabla. But I think, especially as we get into deeper clinical use cases, it's important whenever we can find some surveys and reviews around things that are currently inefficient, or could be improved in health systems. That's really like fuel for our product team to really try to address those. So yeah, that's probably one of the most important things. And I guess when you're also, as you're involved in reflection around agentic AI and what the standards for managing them and governing them should be, I think what's important to keep in mind is always the future use cases, future extensibility. Like you can design a system with the capabilities of today's agents and today's AI models in mind, but you have to think about what about the next wave of models. Today we trust LLMs for certain things, not for others. If I have a model in the future that has a far deeper ability to reason and it's like far more reliable, what would it look like? Would it work the same way with like prompt and input and then produce some outputs and that's it? Or will it work in ways that are fundamentally different? And so whatever abstraction you come up with to deploy AI agents in the system, you want to make sure that it's also that you think one or two steps ahead and that it's also compatible with future paradigms of AI.
All right, everyone is talking about Nabla's exclusive partnership with Advanced Machine Intelligence, founded by Jan LeCun, that will focus on advancing world model technologies. What would you like to add about this partnership that maybe you haven't had an opportunity to frame for maybe a more technical audience?
Yeah, so obviously, the whole world is getting amazing results, using LLMs for very different use cases today. And I think, everyone, even if you're like you're a user of those types of technologies, you definitely notice where it still falls short today. And so world models are really, a way, an idea to lift some fundamental limitations of the LLM architectures that we have today. So today there are like many frontier labs that are investing many billions trying to make LLMs better, and that's amazing. But I think it's also important to keep in mind that there's no guarantee that and just making bigger and bigger LLMs powered with more and more data will naturally, take us to systems that reason on the same level that humans do. And in particular, there are some pretty strong arguments you can make in terms of, how much data, humans when they are born are exposed to, and the way in which they reason, and the types of mistakes they do and types of mistakes they never do that LLMs actually do. That is enough to make a strong point that we're still missing something to truly replicate something that is like human intelligence. So fundamentally, LLMs are really about producing some data that looks the most like what was in the training data. And there are lots of tricks that you can build around that, and things like chain of thought, reasoning, and all that. But this is what they are. Those are only tricks, but it does not fundamentally address the core problem. And so the whole point of the partnership with AMI is to actually help test and validate those new model architectures, given the very promising results, research results that have been reached recently on specific use cases, because you can't develop AI in a vacuum. And so the promise is that at the architecture level, you get something that is a lot more powerful in terms of reasoning, also a lot more explainable, because concretely, you will have a concept of simulating the world, through your world model. And you are going to simulate the consequences of making specific actions, assign probabilities to specific events, and actually, try out multiple things, which is a lot more, human-like and powerful compared to having only a single thing you can do, which is immediately predicting your output, which is what LLMs do today. So the promise is that it can actually make models that fail far less often and never make the types of silly mistakes that LLMs sometimes do. And sometimes you can see those mistakes, and you can see kind of why they made the mistake, because there's something in the training data that probably looks like that. But at the same time, you can't help but think that a human would never have made that same exact mistake. It's just like, bad correlation between different pieces of data. So the idea is to lift those fundamental limitations. And in the process, there are also high chances that you can also be way more data efficient and use far less processing power to do similarly powerful predictions. And data efficiency, it's good because you also reduce the amount of compute that you need, but also the more specific your use case is. And for healthcare, there are many very specific topics, very specific use cases for which the total amount of data that is available today in the world would not be enough, for the problem to be solved with an LLM approach. So we have to be way more efficient. We need to find models that are way more data efficient if we want to have any hope of solving those problems one day. So that's the meaning of the partnership.
Martin, I'd like to switch subjects and talk about inference optimization in computational health. At the University of Pittsburgh, we're particularly interested in advances and challenges at the AI inference layer. Thinking about AI models and world models, what are your views on inference optimization?
So first, making inference efficient is an important problem. We try whenever we, solve specific problems with Nabla, add like new use cases to use, the right flavor. There are often large language models involved today. So you want to make sure you use the right one with the right size. You don't want to use a giant model if it's not needed. Sometimes you want actually a smaller model that is more specialized, that you can directly fine tune. And that also helps you control your latency, which matters in the product because you want to be able to generate information and actions quickly. And so there's a lot of effort that goes into selecting the right kinds of models, building the right kind of infrastructure so that you can, many millions of inferences every day at scale. And the one reason we are particularly excited about world models is not only that the promise is that they can be way more efficient for many types of computations, but also it will change, I think, the paradigm of training versus inferences in many cases. Because if you think of human intelligence, one aspect of it is that it's very continuous. Over your life, you're going to experience things, and then you're going to adjust your weights in your brain in some way, and then you're going to learn very continuously. And sometimes in the ways we use LLMs, you can see that there's a bit of that where you add more and more things in the context. And so sometimes if you give feedback, you may have some strategies where you are going to add something more to your context. And that simulates learning along the way, in some way. But the problem with LLMs is that at some point you fill up your context window, and you can have all sorts of tricks to compress the context and make the most efficient use of it. But still, the amount of total available context will be limited, and there's nothing within the network that is truly learning over time. And so I think world models have the potential to actually blur the frontier between training and inference a little bit. And so they will be way more efficient. So it's going to be less of a problem, because today training is a very resource intensive process, but you will have to think probably a bit more in depth about the pipelines and the overall life cycle of data and how models evolve over time based on available data. What is specific to a specific clinician, specific to an organization, and that will raise all sorts of interesting topics. But yeah, continuous learning is probably the biggest thing that will change how we think about inference today.
Before we close, we like to ask all of our guests to offer students a research project idea. But if you had a twin at NABLA who could fill your shoes during the day, what's something hugely challenging or highly interesting that you'd love to work on yourself?
I mean, there are lots of things I could work on that I think would be great if students actually address. I think the most important thing is either a student or I have some lots of extra free time would be spending more time to think more outside the box. There's there are so many new ideas coming up today on how to use available technology, and so there's not enough time to really explore everything in depth. So you have to use your intuition a little bit, to think this is one idea that I think is worth pursuing. But I think there are lots of ideas that are more outside the box, and I think world models is just one idea. But if you zoom back a little bit from solving one specific use case, but you think more in terms of what is human intelligence, there are lots of things you can do with the compute available today that are worth exploring further, especially things around emergent intelligence, emergent systems, and how the collaboration between many different models can give rise to patterns that are maybe more interesting than what a single model would do. So those are really like long-term research ideas that are probably underexplored today, in spite of the huge amount of funding that goes into AI today. And in terms of, I think, problems that aren't fully solved yet and that are maybe more shorter term, there's more and more what is called computer use models that are available today, things that allow AI to directly interact with human-computer interfaces and click on buttons and all that. But I think the state of the art today is not yet fully satisfying. I think there's a lot more improvements that are needed to be able to automate things fully reliably at a very large scale. So there is more research being done in that area, and I think there's a lot of interesting research you can do without necessarily having access to huge clusters of machines, having access to supercomputers. I think right now, if you zoom into how computer use models actually work, there are still parts of the system that are actually quite basic. And I think this will be an important aspect of automating workflows, either clinical or not clinical in the future.
This is an open-ended question, but to close our interview, Can you share for us what you're excited about at Nabla at this moment?
Yes, what makes us super excited, to start working every day is the constant stream of feedback we receive from clinicians using the products across the world. And I think that's way more powerful actually that, of course there are great, usage curves, and you can look at all the clinicians that are using Nabla every day. But I think getting, real world feedback from someone whose life was changed, whose professional life was changed as a result of using this type of technology, this is the most energizing thing there is, that really wants to help us do as much as we can to reduce the burden of that clinicians still experience today. And I think there's still so much more to do. Like ideally, every clinician would have the perfect human assistant that understands everything, that you can coach over time, and that assistant will even be able to help you get better as a clinician over time. And so I think today, we're expanding the set of use cases, but there's still a lot of exciting things on the roadmap to make the whole continuous improvement process, much more powerful and smoother. And also our ability to tackle even use cases that we didn't have to think of beforehand, but giving more tools to clinicians to actually say, hey, this is something I think we should be able to automate, and having Nabla give you the tools to actually do that and roll out those new use cases yourself. And so for that, it's not just a matter of saying, hey, Nabla is connected to lots of things, and so there are many things you can do now, but you need to have strong foundations and help the clinician understand what the possibilities are. So a lot of it will come from working hand in hand with clinicians. And for sure, Nabla, we won't be solving all the use cases by ourselves. It will be a large-scale collaboration with clinicians across the world to make healthcare more efficient and improve care outcomes for patients as a result.
Thank you so much, Martin. That was a great closing. And it's been a pleasure speaking with you. Thanks for taking the time to join us on Pitt's Health and Explainable AI podcast. From the University of Pittsburgh, thanks everyone for tuning in and for following the series. Join us again on HexAI, where we explore the transformative integration of responsible and explainable artificial intelligence into health informatics, clinical decision-making, and computational medicine.